Whew. Oh. Hey, let's talk about for loops. So there are two main types of for loops in the Java language: while loops and for loops. And both of them are used kind of interchangeably, but they have certain categories where they really work better. So let's first talk about while loops. A while loop says while some condition is true, keep doing something. Now, typically while loops are used when you don't know how long something's going to continue. While it's raining, hold up your umbrella. I don't really know how long it's going to rain for, so I just keep holding my umbrella up the whole time. So you might have a while loop set up like this. While it's raining. And then you might say have something in your code that says, check out the window. Because we always got to make sure we have some way of changing the condition inside the loop. But you don't know how many times this loop is going to go. You might have other loops, or other versions of a while loop, where instead of saying while it's raining, you might say int x equals 0, while x is less than 10, do something and count, make x bigger, x plus plus. Now, this is perfectly acceptable, but it's really kind of what for loops were meant for. So a for loop says for a certain number of times. For each person in the room, for 10 seconds. So a for loop implies you know how many loops you're going to make. A while loop implies you don't. So until in English tends to mean while loop. For always means for, or each usually means for loop. So let's look at the syntax of a for loop, because it's a little bit different, and it looks a little scary at first, but it's really not bad. Alright, so a for loop starts with the word for, and then it gets a big set of parentheses, and then has the code that you're going to repeat. So it might be something like system.out.println something. Maybe we're just going to print something. So a for loop has three different parts inside of this set of parentheses here, separated by two semicolons. Now, these three parts are meant to help count. So the first part is called initializing the iterator. Initializing the iterator. An iterator is just something that you count with. So for instance, if we were little, we might initialize our iterator by picking up our hands, because we count on our hands. This is my iterator. So 1, 2, 3, 4, 5, 6, 7. Hey, where am I at? Oh, 7. My hands are keeping track of where my place is. So a computer needs something like that too. It's not going to use fingers, but it'll use something similar. So the first step is, what are you going to count with and where are you going to start? The second part is really when you're going to stop. So this is the condition. How do you determine when you're done counting? And the third step is, well, what are you going to count by? Because I can count by 1s, or 2s, or 3s, or 4s, or 5s. Watch. 0, 5, 10, 15, 20. Pretty impressive. The computer can do it too, but we got to tell it how much to count by. So this part is called the iterative step. How big is that step that you're going to take? So let's actually put in some code for this. Alright, initialize the iterator. Well, because it's really easy to count using numbers, that works real well for the computer. So we're going to give it a number, an integer number, int, and then we're going to name it I for iterator. This is kind of our normal default name for loops. Int I equals 0. We don't have to start at 0, but that's typically the default starting location for counting, especially on a computer. Condition. Well, let's say we wanted to count to 10, or count to 20, or do something 5 times. Well, whatever the number is that we care about, typically right here. So let's say I want to count to 10. 10, and I'd say I is less than 10. So you may recall from the while loop video, when we printed out our numbers, we counted 0 through 9, which is 10 numbers. That's what this is going to do. 0 to 9 is 10 loops. Now the last thing, the iterative step, how much do we want to count by? 99% of the time we want to count by ones. And the easiest way to do that is I plus plus. So, for an integer called I, which equals 0 to start with, while I is less than 10, do this. So let's print out, for instance, I. That could be the code that we do. Now the one interesting thing about a for loop is the way that you navigate it. So we're doing our program, navigating the code, we see a for loop, we go, oh, a for loop. Well, let's get started. And we check this first little spot and make an iterator. Oh, cool, I is 0, that's really neat. Well, should I go and run the code? I don't know, I better go check the condition. Oh, 0 is less than 10. I passed the condition, so let's go run the code. Cool, I'm printing out I. My output is going to be 0. Now what? Let's see if there's anything else. Oh, that's it, the code's done. But wait, there might be more. So let's run all the way up to the top, stop by the iterative step, so now I is 1, and then go check the condition again. 1 is less than 10, so I print 1. Go back, iterative step. I plus plus becomes 2. 2 is less than 10, 3 is less than 10, and we keep going until eventually we get to 9. 9 is less than 10, I print 9. I go back, I becomes 10. 10 is not less than 10, so I've done the loop, done the for loop. So, for loops, just like while loops, they are laid out a little bit differently, but you're going to come to love them. Bye now.